to discuss quicksort algorithm in this video. Quicksort is another efficient sorting algorithm which follows the divide and conquer strategy here. So again the quicksort also follows divide and conquer strategy. It works by selecting a pivot element from the array and partitioning the other elements into two subarrays. So here in quicksort the partition of the list is performed based on the element is called a pivot, because when we take merge sort algorithm, here there we directly we start dividing the list into two subarrays, but here in quicksort we are not going to directly segregate the list into two different sub list. First we have to fix the pivot element and we perform some process over there. Based on the processes, finally at certain after certain point we would be just swapping the pivot element with some other element. So once swapped, once the pivot went to its right position, other than the pivot all the remaining elements would be considered as the different list. The element which are left to the pivot element would be considered as the left subarray, and the elements which are right to the pivot element would be considered as the right subarray. So here the partitioning of the array is mainly based on only the pivot element. So the list is divided into two partitions such that all the element to the left of pivot are smaller than the pivot, and all the elements to the right of pivot are greater than or equal to the pivot. So both are considered as two different subarrays, left array as well as the right subarray. Now let's discuss one example and we'll try to apply quicksort on this. So there is an example. This is the example unsorted array which has only 5 elements in the list. Before we start solving an example, like a few steps I just want to discuss here. So the very first step is here in the quicksort algorithm. You have to fix the pivot element. So you can fix either first element as the pivot element or last element as the pivot element. So here in this current example I am going to consider the first element as the pivot element. So the very first step is consider first element as the pivot element. After considering the first element as the pivot element, the second step is define two variables I and j. So the I would be pointing the next position of the pivot. So I pointer would be pointing next to the pivot element, and j pointer, the j variable would be pointing the last index. So defined two variables I and j. Yes, second step is also over. Then the third step is we are supposed to compare array of array of I and as well as array of j with the pivot element. So first we will start with I. So you have to check whether the array of I is lesser than the pivot. Only if array of I is lesser than the pivot element, you will be able to increment the I pointer. So only if I is lesser than the pivot, you can increment the I pointer. So once incrementing the I pointer is over, then you can move on to the j pointer. Check whether j is greater than the pivot, so that you will be able to decrement the j. So to increment I, array of I must be lesser than the pivot. To decrement j pointer, array of j must be greater than the pivot. So these are the conditions. So we'll see one by one, and then you have to check again I is lesser than j if I is lesser. So the remaining two steps will be discussed later. First we'll try to implement first 4 step. Yes, we have considered first as the pivot element, it's done. Defined two variables I and j. So I is pointing index 1 and j is pointing index 4. Now you check whether I is lesser than the pivot element. Yes, array of I is lesser than the pivot element only. Array of I is 40 and array of the pivot element is 60. So 65. So I is lesser than the pivot element only. If so, I can be incremented. Again you check whether I is lesser than the pivot element. I is 75 and pivot element is 65. So array of I is not lesser than the pivot element, so I cannot be incremented. So since I cannot be incremented, you just move on to the j pointer. So first you have to complete incrementing the I pointer, and then only you have to move on to the j pointer. Now check the j pointer, because I cannot be incremented anymore because the condition is not satisfied here. Array of I is not lesser than the pivot, so I cannot be incremented. Now move on to the j pointer. So if you check j pointer, array of j is 45 and pivot is 65. So the condition here is you can decrement j. So I should be incremented and j should be decremented. You can decrement j only when array of j is greater than the pivot element. So if you check array of j, it is 45 and pivot is 65, which means array of j is not greater than the pivot element, so j cannot be decremented. So I I cannot be incremented anymore, j also cannot be decremented anymore. And at this stage we have to check whether I is lesser than j. Fifth step, check the fifth step. Yeah, check whether I is lesser than j. Yes, I is pointing 2 and j is pointing 4, which means I is lesser than j only. If I is lesser than j, you're supposed to swap array of I and array of j. So in the next step, I is lesser than j, so swap array of I and array of j. So only when I is lesser than j, you can perform swapping between array of I and array of j. So now the updated array is going to be 65, 40, and array I and j you are supposed to swap, right? So 45 would come here and 75 would go there and 80 would remain in the same position. So this is the updated list, and still I and j would remain in the same position only even after performing the swapping operation. I was pointing to, j was pointing the index 4. Now again you check, you just repeat the process steps 3 and 4. If array of I is lesser than the pivot, yes, array of I is 45 and pivot is 65, right? Yes, I is lesser than the pivot element, increment I. So I would be incremented. Check I again, array of I is 80, pivot is 65, array of I is greater than the pivot element, so I cannot be incremented. Move on to j. Check array of j is greater than the pivot element, so j can be decremented. So now j is pointing the index 3, I is also pointing the index 3. Now again, so I cannot be incremented because the condition is not satisfied here, so we are concentrating on j pointer now. Now j, array of j is 80 and again the pivot is 65. Compare 80 and 65. Yes, again array of j is greater than the pivot element, so decrement j one more position. So now j would be here. J is pointing 2 now. So now again if you check, j cannot be decremented anymore because array of j is lesser than the pivot element, so j cannot be decremented anymore. So I cannot be incremented, j also cannot be decremented. Now you check whether I is lesser than j. Check for the fifth step. No, I is not lesser than j, I is greater than j. I is pointing 3, j is pointing 2, so I is greater than j. If so, move on to the sixth step. So if I is greater than j, swap array of j with the pivot element. So where you can't increment I and you can't decrement j, you have to check for two conditions. First is step 5, I is lesser than j. If I is lesser than j, swap array of I and array of j. If I is not lesser than j, if it is greater, means swap pivot and j. So check for the sixth step. Yes, if I is greater than j, we are supposed to swap array of j and pivot element. So in the next step, so array of j and pivot should be swapped here, right? So array of j would come here and pivot would go there. Rest all other elements would remain in the same position. This is the current list now. If you check, so this here our pivot element is, right? So this is our pivot element. If you check our pivot element, once if you change the position of pivot, once if you exchange the pivot element with the j, the pivot element would always come to its right position only. Now if you check, 65 is in the correct position. If you check the entire array, the pivot element 65 is in its correct position only. So you no need to touch this element anymore. Why? Because it's already in the right position. So you are supposed to focus on the remaining elements. So once the pivot is swapped, all the elements which are left to the pivot element would be considered as the separate subarray, and right to the pivot element would be considered as the another subarray. So now the list is getting subdivided into two. This is our left subarray and this is going to be our right subarray, right? Again, the same processes, all these same steps you are supposed to apply again on the left sub problem as well as on the right sub problem. Let's discuss now, and let's continue solving the problem. I'll copy down the list again so that it would be more clear. So this is our current list. Now pivot is in the right position, so you no need to touch the pivot. You're supposed to concentrate on the left subarray as well as the right subarray, right? So as usual, again our concept is fixing first element as the pivot element. Once the pivot element is fixed, the second step is define two variables I and j. I should point the second element and j should point the last element. Yes, I is pointing the second element, j should point the last element. 40 is the last element only, second element as well as the last element, because in the left subarray there are only two elements. We fixed first as the pivot element. Both I and j would be pointing the same element because there is only one element remaining here. If you check the right subarray, again fix the first element as the pivot element and define the variables I and j. Since there is only one element remaining, both I and j is going to be same only. Now we will start solving it. Compare pivot element with I first. So when it comes to I, array of I must be always lesser than the pivot element so that I can be incremented. So if you check array of I with the pivot element, yes, it is lesser than the pivot element, so I can be incremented. So I is here now, like 0 1. So if you increment I, like the I would move to the second index, but there is no second index because the element is over. There are no more element in the left subarray, right? So I is incremented. Anyhow the I is incremented. We can't increment I anymore because there are no more elements. So come to j, since I cannot be incremented anymore. If you come to j, j must be greater than the pivot element, but it is still lesser only, so j cannot be decremented. So I cannot be incremented, j also cannot be decremented. Now we have to check whether I is lesser than j or greater than j. I is not lesser than j, it is greater than j. If so, we are supposed to swap j with the pivot element. So j and the pivot element you are supposed to swap. So 40 is coming here and 45 is going there. So now once the pivot element is swapped, always if you are changing the position of the pivot, it would always go to the right position only. So we swapped the pivot. Now if you check, yes, the pivot is in the right position only. See, if you check, already 65 was in the right position. If you look at the left subarray, we swapped again the pivot element to 45. So 45 is also in the right position, right? Again, if you check, the current pivot was 45. So the element which are left to the element is going to be, the remaining elements are going to act as a left subarray. Right to the pivot is going to as a right subarray. But right to 45 there is no subarray. Only left to its 45 there is a left subarray in which there is only one element is there. When there is only one element, like the algorithm doesn't work here, so it would retain in the same position only. So the left subarray is completely solved. Now you just move on to the right subarray, fix first element as the pivot element, and both I and j is going to be same. Compare pivot and array of I. According to array of I, it must be lesser only. Yes, array of I is lesser than the pivot element, so increment I. You can't increment I anymore because there are no more elements to consider. So come to j. J should be always greater than the pivot element. So if you check array of j, it is coming lesser than the pivot only. So j cannot be decremented. I also cannot be incremented anymore, and j also cannot be decremented anymore. So in this scenario, check whether I is lesser than j. No, I is greater than j, which means I and j are overlapped. Means you can blindly start swapping the pivot element along with the j, array of j element. So I and j are overlapped, so you can swap the pivot element along with the array of j element. So in the next step, yeah, we are swapping it, so array of j would come here and the pivot would go there. So now if you check, already 65 was in the right position, 45 also was in the right position, and now you swapped the pivot, right? So this pivot also is in the right position, right? If you check, the pivot left to the elements which are left to the pivot is going to be the left subarray, right to the pivot is going to be the right subarray. There is no right subarray. If you check the left subarray in which there is only one element, again the algorithm doesn't work on a single algorithm because when there is only one algorithm, the sorting is not required over there, so it will remain at the same position. So we now anymore the algorithm cannot be applied, any more process cannot be applied. So now if you check, the list is completely sorted. So here either you can fix the first element or last element as a pivot element here. So once the pivot is fixed, we are supposed to perform the comparison with the I variable and j variable, and we have to swap the pivot element. Once the pivot is swapped, other than the pivot, all other elements would act as a different subarray. So you apply the same process again and again and again until the complete list is sorted. This is how the quicksort algorithm works. Let's take one more example. Second example is 25, 23, 28, 21, 24, 26, 22, 27. So let's fix the first element as the pivot element. Next to the pivot is going to be the I variable, and last is going to be the j variable. We'll start comparing I and j with the pivot element. Check whether array of I is lesser than the pivot element. Yes, if it is lesser, you can increment your I. Again, check I whether I is lesser than the pivot element. No, I is not lesser than the pivot element. So you start focusing on j. So j should be always greater than the pivot element so that j can be decremented. So j is pointing here now. Again, you compare whether j is greater than the pivot element. No, j is not greater than the pivot element. So I cannot be incremented, j also cannot be decremented. In this scenario, you are supposed to check whether I is lesser than j. Yes, I is lesser than j. If so, you can swap array of I and array of j. So if you swap these two elements, in the next step you would get 25, 23, 28, 22, 21, 24, 26, 28 and 27. We perform the swapping among I and j. Now again the I would remain in the same position only. I would be pointing the same position, j also would be pointing the same position, and this is going to be your pivot. Again you start comparing it whether array of I is lesser than the pivot. Yes, increment I. Again I is lesser than the pivot, increment I. I is lesser than the pivot, again increment I. Again check array of I is lesser than the pivot. No, array of I is greater than the pivot, so I cannot be incremented. Go to j. J is greater than the pivot. Yes, decrement j. Again array of j is greater than the pivot. Yes, decrement j. Again you check whether array of j is greater than the pivot. No. So now you check I cannot be incremented, j cannot be decremented. So now you have to check whether I is lesser than j or greater than j. No, I is greater than j. If I is greater than j, you are supposed to perform swapping operation between pivot and array of j, which means pivot and array of j would be swapped now. So in the next step, 24 would come here and 25 would go there. Rest all would remain in the same position. 26, 28, 27. Now if you check, pivot has come to its right position, right? So except pivot, all the remaining elements would come to would be considered as the left subarray. So this is our left subarray, and all these elements would be considered as the right subarray, right? Again you start applying the same process again and again until the complete list is sorted. So now if you check the left subarray, again fix first element as the pivot element, then define the variables I as well as j. I should point the second element, and j should point last element in each array. So now compare. So again this is going to be the pivot, this is our I, and this is our j. First we will solve the left subarray and then we will move on to the right subarray. Compare array of j and I and pivot element. Yes, it is lesser only, so increment I. Again you compare array of I with the pivot element, it is lesser only, so increment I. Again if you check array of I is lesser than the pivot only, increment I. Again you check array of I along with the pivot element, there are no more element after 25, so I cannot be incremented anymore. Check j. When you check j, whether j can be decremented, check array of j is greater than the pivot element. No, array of j is not greater than the pivot element, so j also cannot be decremented. I cannot be incremented, j also cannot be decremented. In this scenario, I is greater than j only, right? So swap pivot and array of j. So these two you are going to swap. So if you swap, 21 is coming here and 24 would go there. So 23, 22. Already 25 is in the right position only. 26, 28 and 27 would remain in the same position. So now if you check, already 25 is in the right position. Now 24 also is in the right position, right? So now 24 came to the right position. If you check, like the element, the 24 is our current pivot element. So the element which are left to the pivot element is going to act as left subarray. Right to the pivot element there are no more elements, so no right subarray for the second, during the second iteration for the left subarray element. So only left subarray only. Again apply the same process. Fix first element as the pivot element. Define I variable as well as j variable. If you check, compare array of I along with the pivot element, it should be lesser, otherwise you cannot increment I, right? So I is not lesser, so you cannot increment I anymore. Check j should be greater. Yes, j is greater, so decrement j. Check again array of j with the pivot element. Yes, array of j is again greater only, so j would come here. But if you check, okay, again array of j is now if you check, pivot element as well as array of j is same only. So and also if which is same, which means what, only if it is greater the j can be decremented. But if you compare the pivot and array of j, which is, since it is same, j cannot be decremented anymore, right? So I cannot be incremented, j also cannot be decremented. So here you have to check whether I and j is greater or lesser, because both cannot be incremented and decremented. So if you check, I is greater than j, so we cannot swap I and j, right? Because I is greater than j, you can swap only pivot and array of j, right? Since pivot and j are same, like it would swap with itself, because both are same element, so it would swap with itself only. So 21 would still remain in the same position only. Then 20, which means the swapping is getting performed, but it's getting performed with itself. 24, 25, 26, 28, 27. So already 24, 25 are in the right position. Now in the previous iteration, like we swapped it, pivot element 21 swapped by itself, right? Since the pivot and j was same, so this also is in the right position. So the element which are left to the pivot is going to be the left subarray, right to the pivot is going to be the right subarray. So there is no left subarray for this 21. If you check right subarray, again there are two elements. Apply the same process again. This is our pivot. Both I and j is going to focus the same element. Why? Because there is only one remaining element is there. Check whether the pivot is greater than I. Sorry, pivot is yes, pivot is whether the array of I is lesser than the pivot element. You have to check. Yes, it is lesser than the pivot element. Increment I. Again check array of I with the pivot element. There is no array of I, so I cannot be incremented anymore. Come to j. Whether array of j is greater than the pivot? No, array of j is not greater than the pivot, so j also cannot be decremented. Now if you check, I is greater than j. When I is greater than j, swap pivot and array of j. Now 21 was already in the right position. Swap pivot and array of j. So array of j would come here and pivot would go there. And 24, 25 remaining all will be retained in the same places only. So already if you check, 24, 25, 21 were in the right position. Now recently we performed swapping between the pivot and j, which means the 23 also is in the right position. So left to the pivot, if you check, there is only one element. Left to the recent pivot, if you check, there is only one element, which is going to be considered as the left subarray. But if you check one element only, so the algorithm doesn't apply over here, because there is only one element. The sorting algorithm cannot be applied, which means all these elements are completely sorted. Now you focus on the left subarray. Fix first element as the pivot element, second element as I, last element as j. Apply the same process again. Compare a pivot with array of I. Array of I must be lesser. It is not lesser, so I cannot be incremented. Check j. Yes, it is greater only. If it is greater, decrement. And then again array of j is greater than the pivot element, decrement. Now again you check whether array of j is greater than the pivot element? No, it is not greater, it is equal, so j cannot be decremented anymore, I cannot be incremented anymore. So here you have to check whether I is greater than j or lesser than j. I is greater than j. If I is greater than j, swap pivot and array of j, right? Which means you are supposed to swap pivot and array of j, both the same element only, so the swapping would be performed with itself only, which means 26 is going to remain in the same position, which is going to be the right position. So 21, 22, 23, 24, 25, 26 would remain in the same position because swapping is performed with itself, which is in the right position only. So if you check, already 21, 22, 23, 24, 25 it was in the right position. Now recently we performed the swapping with the p and j again, so till 26 it's in the right position. So for this pivot there is no right subarray, only left subarray is there. Again you try to solve this, sorry, no left subarray, only right subarray is there. So again you try to solve this right subarray. First is the pivot element, rest all is going to be like, for the second is going to be I, last is going to be j. Since there is only one, both I and j is going to be pointing one element only. Now compare array of I and j. Array of I is lesser, so I can be incremented. Again check array of I and p, there is no array of I, so I cannot be incremented. Check j. Array of j must be greater, but array of j is lesser only, so j cannot be decremented. So incrementing as well as decrementing cannot be done here. So check I and j, I is greater than j. So swap again pivot and array of j. Now you would be swapping the pivot and j. So 21, when the resultant array is going to be in the next step, 27 would come here and 28, which is the pivot element, will go there. So now 28 also is in the right position. So till this element it was in the right position only. So now we perform swapping between the pivot and j element. So which means this element also, since this was the pivot, this is also is in the right position. So now there is no right subarray, but there is a left subarray in which there is only one element. Again the algorithm doesn't work there when there is only one element. Sorting algorithm is not required, right? So the process stops till here. So if you check, this is going to be our final list and it is completely sorted only. So the same procedure, these 5 steps which we are supposed to, 6 steps which we are supposed to follow until the list is completely sorted. So this is how the sorting algorithm works. Let me give you one exercise problem. Please try this out. Seven, 2, 1, 6, 8, 5, 3, 4. So you can fix either the first element or last element as the pivot element. So here I have taken first element as the pivot element. If you wish, you can take last element also as the pivot element and apply the same procedure again, it would work. Thank you.